But now the concept will going to be a more complex as we are going to proceed with the different components and the value that has came up from them and the further reaction of them. Okay, so as I have already told you, what is an electric current? I have told you that electric current is the flow of charge across a cross section per unit time. Suppose they have considered, yes, over here. Suppose they have considered that cross section. Suppose that is the cross section for them, and they are checking out how much electron is just passing through that particular area. So whatever would be, you can say, suppose this is the cross section. That will be better to understand. Na? So over here, suppose that is the cross section. That will be the better idea to understand. So we will going to just check how many positive charge has been passed. Really, a positive charge? Yes, they have showed up. All the positive charges are moving in a wire. Now, as I've already told you, there is nothing which is related to a positive charge in a flow of electric current. Okay, so what is an electric current? Electric current is always a flow of electrons, and that flow of electric current, if electron are moving in this direction, then my current will going to move in this direction. That means electric current is just opposite to the flow of electrons. This much we know. And now I'm going to tell you a very interesting thing. See over here, as you have seen, these all blue lines are the electrons. This one, these blue lines which are going on in this direction, they are the flow of electrons. And see, if you can see that red line, that is showing up electric current. That means if electrons are moving in this direction, then current will going to move in this direction. Also, the positive charge will going to move in this direction. Similarly, as we have seen in that red flow of charge, they are basically considered as positive charge. Again and again, I'm telling you, there is nothing like flow of positive charge. Only the flow of electrons, the opposite direction to the flow of electrons, is considered to be a flow of positive charge or a flow of current. So I can say that electrons are attracted by positive terminal of a battery. So we can say that positive charge are moving away from the positive terminal, and they enter into the negative terminal. That's why we can say electric current always move from positive terminal to the negative terminal. So now, very important approach in electricity and electric current. Guys, what actually happened? Sir George Simon Ohm, he was a great scientist. So Sir George Simon Ohm was doing some kind of experiment, and when he noticed that in a particular electric circuit, I have told you what is an electric circuit. A number of connections, number of components, electrical components are connected through a wire in a closed circuit or a closed loop. Then they have provided some kind of supply with a battery or a cell. Okay, so once upon a time, one day, George Simon Ohm was doing some kind of experiment with an electric circuit, and what he noticed? He noticed that if there was first battery, suppose that is an emitter. I have already told you what is an emitter. Emitter is a device which is used to measure the electric current. Okay, can I do it in a nice writing? Okay, I'm doing it. I'm writing in this emitter. And in this, we have noticed, Sir George Simon has noticed that wherever the number of cell has been increased, the emitter shows larger amount of current. It was a great approach. He did many a times. First, initially, he just applied a single battery. Then emitter has showed up a small reading like this. Okay. But When he increased the number of cells. Initially, when there was one cell, the current was showing up a lighter increase. After that, he increased one more cell. There were two cells now. Then current got increased a lot. Then after this third cell, he checked out the current got increased a larger amount. So he did this experiment many a times. What he noticed? He noticed that electric current flows through a wire will be directly proportional to the potential difference across the ends when temperature remains constant. It is not only temperature, pressure, any kind of physical condition which can affect it. Everything was considered over there. So guys, what they noticed that if the voltage, whatever amount the voltage is increased, the current will increase in the proportional way. If voltage, suppose, let me do that in a particular way. Over here, he noticed that if the voltage and current were checked out, they have noticed that if my voltage is 10 volt, current was suppose 0.1 ampere, then my voltage was 2 volt, current was about 0.2 ampere. If my voltage was, sorry, not 2 volt, 20 volt. Okay, I'm not gonna mark this unit now. It is already given above. It is in volts. That will be in ampere. Okay, so 10 volt, 20 volt, then he increased it to 30 volt, then 40 volt. Then he checked out the current was increased linearly, 0.4. And by that, he just found out a ratio that is V upon I. What is that ratio now? Then that ratio that has been came up, that is 10 upon 0.1, it was 100. Then 20 upon 0.2, again 100. Then 30 upon 0.3, again 100. Then 40 upon 0.4, again 100. So guys, this has created a great approach towards an electric current. They said if we used to increase a voltage in a particular, if we used to increase a potential difference or a voltage across any end, then the current across them will also increase. Okay, so, and they were directly proportional. Okay, and by creating a graph of it, they formed a graph, they found a linear graph for it. Okay, so that law has been stated as Ohm's law. Okay, and this law was so simple and it is too basic to understand, because we cannot go through any kind of approach on this. See, whatever they said, if they have current like 0 0.1, 0 0.2, 0 0.3, 0.4, 0.5, then it will be 10 volt, 20 volt, 30 volt, 40 volt, 50 volt. So if 10 volt has been increased, 0.1 ampere has been increased, then again 10 volt has been increased, again 0.1 has been increased, then again next 10 volt has been increased, then again 0.1 ampere current has been increased. So they have found out that the potential difference across an end is directly proportional to the current across that current flows through the particular circuit or a combination or connection, whatever it is, or wire. Okay, so I can say voltage is directly proportional to I, and they have named it. What is that constant of proportionality called as? That constant of proportionality is defined by resistance. As you have seen, whatever value we got, V, then I, then V upon I, the values were like 10, 0.1, output 100. Then 20 upon 0.2, 100. Then 30, 0.3, 100. 40, 0.4, 100. So they have noticed whatever would be the variation in voltage, whatever would be the variation in current, they are increasing directly, they are varying directly proportionally. All right. And that proportionality constant is always constant. So what is that constant called as? That constant called as resistance. And that is called as resistance of a wire. We will going to explain it again. Okay, so guys, I hope it is all clear to you how George Simon Ohm has stated a law which is defined as Ohm's law. Okay, after concluding all this, they have found out a new concept that is related to resistance. What they said basically, that resistance is an opposition. What is that? It is going to make me a lot of confused. So guys, be chill. It is not that much difficult. Suppose you are going on a highway and there are hardly one or two vehicles on the road. What will be your speed? It must be 80, 90, 100, 110, 120. Right? Because the whole road is clean. It's just an expressway. It's just a highway. And highway means high speed. After that, you just enter into the market area. And in that market area, on the same road, there are about 50 vehicles. One, then after one, then there would be a heavy traffic jam. What will be your speed? 20, 30, 0 many a times. You need to apply the brakes. Why so? To avoid collision between the vehicles. Right? So, in a similar manner, okay guys, in this particular scenario, as I have told you, a complete highway in which hardly one or two vehicles are there, your velocity will be 50 kilometers. No, not exactly 50. It should be 90, 100. The velocity will be 90 kilometer per hour. And if the road got congested, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30. There are a huge number of vehicles. Then there will be a traffic jam. And in that traffic jam, your velocity will be 20 kilometer per hour. Okay, so this is not a thing that you will not going to pass through that highway. You will definitely cross that highway, but it will take larger time to cross that highway. All right, because what's the reason to cross that highway? Because there are number of vehicles, and to protect yourself, you need to do what? What do you need to do? You need to slow down your speed, and you will reach the destination a bit. You will reach the destination a bit later. Okay, so in this particular scenario, I would like to tell you that traffic jam stop you to cross the road. Similarly, when the metal wire got lesser area or has a large number of charge carriers, there is a possibility of large amount of collisions, and that collisions, as electrons move in very high velocity, so whenever this collision occur, that collision will going to stuck your path, and that stuck in your path will going to restrict the velocity of electrons flowing in a circuit. So that flow of electrical current is got restricted, is got is got uh, bounded by a resistance. They want to move freely. So if they want get enough space to move, if they want get uh, high velocity, if they used to collide with each other, they used to do some kind of collisions with each other, they won't be able to move as faster as they were earlier. See over here, if you notice, in this particular path there is a linear, that's a linear highway. Okay, and after some moment, that particular car which is moving in a linear way, I'm sorry, that was, what's the problem, which was moving in this direction, that car is having a linear way right now, so its speed will be very high. And after that, when it need to cross this kind of junction, okay, the area of cross section got lower up, and the number of charge carrier has to flow through it, so they will going to collide with each other, and that collision will going to result in this opposition. I hope my point is clear, guys. See over here, we have just marked on the Ohm's law equation. from there we can say that potential difference V is directly proportional to I. Then I can say V is equivalent to I into R, and this R is the resistance. So to define a resistance, it is just a ratio of V upon I, voltage upon current. All right, change in voltage upon change in current, that is will be the resistance, and it is defined as ohms. The unit of this particular resistance is an ohm. All right. So over here, if you notice that, see, there is no single wire. First thing, there is no any single conductor that do not possess a resistance. You say resistance should be a device. Yes, resistor is a device. Rheostat is a device. Then variable resistors are there. But when we say a conducting wire, every conducting wire is a thin wire made up of metal and free electrons, and whenever they flow from one direction to another direction, they always collide with each other. Few times, few moments, it got strike with each other due to lesser cross-sectional area and larger length. So larger will be the length, radius will be higher. So larger will be the area, the area resistance would be lesser. As highway got the width of the highway got increased, then vehicles have enough space to move without any collision. If the space is less, they won't be allowed to move. All right. So over here, if you see that, what is electric resistance? They used to show up this electrical resistance as a symbol like this. Okay, it is just to denote the restriction. These are the hurdles in the path of the current. Okay, so if we connect a resistor in a path, either we connect a resistor or we do not connect a resistor. If you want to measure particular parameters, many a times you need to apply a few resistors across a circuit, but it is not always necessary to apply the resistors. In itself, its own internal resistance is available. Every conductor has its own internal resistance. So guys, if you all have cleared all these concepts, I would like to tell you that there are many more things still left in resistances also. Before going that, I would like to share one more thing. If I say this is the path from where electrons are passed, okay, and by chance my mood got changed and I have increased its area of cross section. Now still there are those electrons like this. So can you tell me what will be the effect on the resistance of the wire when its area got increased? If you need to go through this highway and there are 3 vehicles, then it will be difficult for you to cross. But by chance they have made a highway like 8-lane highway and it is like this now. In that particular scenario, what will happen? The charge has enough space to move. All right. So in that case, I can say resistance offered by the wire will be less. So we say that R is inversely proportional to area of cross section of wire. All right. One more thing. Now I say you need to cross this whole 5 kilometers of highway with this much of traffic. Which traffic? This traffic. You need to cross the 15 kilometers of highway with this much of resistance. What will happen? This resistance will going to increase, because this is not always necessary that they need to collide 1 or 2. For a 1 kilometer, they collide for 2 times. For 15 kilometers, they will going to collide 30 times. So if the length of the wire got increased, what will be the effect on its resistance? Correct. If we say that resistance will going to increase with length, so R is directly proportional to length of the wire. Correct. Next concept that we are going to study is all about R is directly proportional to L upon A. And to remove this constant of proportionality, we use a term that is called as rho. R equals to rho L upon A. Now, what the hell is this rho? Rho is called resistivity. What is this rho called as? Resistivity. So, what is that resistivity? Firstly, it is a property of a material. Please mind this thing forever. So, resistivity is a resistance. Resistivity is a resistance of a wire of length 1 meter and area of cross section 1 meter square. What does it mean? How a resistance is equal to resistivity? I can prove it. How? See, R is equals to rho L upon A. If my length of the wire is 1 meter square, 1 meter, and area of cross-sectional area is 1 meter square, then this value won't have any value. What will be the value? R will be equivalent to rho. For 1 meter of length and 1 meter square of area of cross-section, then R is equivalent to rho. What does that mean? Guys, whenever we need to find a property of any material, we always need to drag a sample, collect a sample of it, and then just check it out. Likewise, what kind of problem, medical problem you have, a doctor can see, a doctor can explain that with the help of a blood test. He used to withdraw few drops of blood from your body, and he used to go all that few drops of blood going to go for a test, and then you will came to know what kind of problem do you have. Similarly, if we have 1 meter of length and 1 meter square of area cross section, then we can check out what is the resistance, and that resistance will be constant for every wire of 1 meter length and 1 meter square area cross section of same material. That means rho will vary according to material, but resistance can vary with length. Resistance can vary with the help of area cross section, because rho restricted the length to 1 meter and area to 1 meter square. So guys, we can say that resistivity is a property of material and resistance is a opposition to the flow of current. So they are different from each other, yet they are same. Alright, so resistance of a wire of 1 meter length and 1 meter square area of cross section is its resistivity. It is a property of a material rather than resistance is a phenomena. Resistance is a phenomena of opposition to the flow of current. Okay, so this is all guys.